For 17, this is a challenge and will require several steps and the intuition of knowing what and how we found that formula we've been using for the last two problems. So I know an angle, but I don't know the sides that go and include it. I do know two sides, but I don't know their included angle either. But I can find their included angle, and then I'll be golden. So I'm going to, since I want to find this angle, I'm going to drop an altitude down. An altitude means it's coming from this vertex and it's making a right angle with the opposite side. So if this is now a new triangle, 90 plus 65, I need to find the mysterious other third angle. So 180 minus 90 minus 65 gives me 25. So I know this part is 25. This is also a right triangle, so I can find this other leg. Because this length is 4 is the hypotenuse, I can find the other leg. I could use the 25 and do adjacent over hypotenuse and find it using cosine. I can use 65 with the opposite over the hypotenuse and use sine. I'm going to use cosine just because we don't use it very often. So I'm going to do cosine of 25 equals, let's give this a nice, I'm going to call it x, I guess. Cosine is the adjacent over the hypotenuse. I'm going to undo this division, so multiply by 4 on both sides. Plug this whole thing into my calculator, 4 cosine of 25. So x is going to be 3.625. Okay? I'm leaving it as this. I'm going to use the exact value in my calculator. So when I need it, I'm actually going to be using this whole expression. So now I know this side length. I know this side length. So if I want to find this angle, we'll call it angle y. 5 is going to be the hypotenuse from it, since this is the right angle, and x is going to be the adjacent. So if I know the adjacent and the hypotenuse, I'm again going to use cosine. So that means cosine of y is the adjacent, which I'm going to be exact. That's actually 4 cosine of 25 over the hypotenuse of 5. I know you're freaking out. It's okay. We got this, the cosine of 25 over here. We dropped an altitude so that we can make a triangle where we know all 3 angles. Once we know some angles, we can find a mysterious side that's now shared in both triangles. So we found that altitude that both triangles share. It's the height of the triangle. I don't know the base though, so I can't just do height times base divided by 2. You can use this decimal in here. I'm trying to be exact, so I'm using this whole expression instead of the value. So I have the altitude, or that adjacent side, divided by the hypotenuse for cosine of this angle. But I need to find the angle. Do I use regular cosine for that? No, I use inverse cosine. So I'm using inverse cosine of 4 cosine 25 over 5. I'm going to show you that in my calculator. I'm going to do inverse cosine, and my numerator is going to be 4 cosine of 25. I'm closing off all those parentheses, then I'm going to divide by 5 again. Hit enter. So my final angle is going to be 43.527. That's y, that's just this part up here. So this part is 43.527. To get the total angle, I need to add to it 25. So I'm going to rewrite the triangle of what we know now. And this angle is 68.5. Yes, I'm rounding. But this angle is 68.5. That's what I learned and did all that math before, was to find this angle. Now I have an included angle, and the 2 sides, I can use our normal formula, 1/2 times one side times the other side times sine of the included angle. You can use second answer from your calculator to use the exact decimal for this. Okay, so I'm going to show you that here as well. So I'm going to do 1/2 times 4 times 5, and then to reference my previous answer, I'm clicking second answer. Okay, hit enter, so I get 685. So the area is 685 to the nearest tenth, so 0.3. And we don't have units, so we're stuck there.